Okay, so we're back here with lesson 4.4, so we can finish this up. Before we get started, I just want to go over how to do some logs on the calculator. So the last thing we had done when I left off yesterday was evaluate these 4 logs here using our calculator. And these were quite straightforward because they were just logs with the common base of 10 or the ln, which is your log with base of e. And all of those have buttons on the calculator, as you see over here on this left side, the ln and the log. So those, you just put them in right away. So what I want to show you is how to do it with a base other than 10 or other than that base of e. So in order to do that, let's just go back to the beginning of our notes where we had a couple examples in this other format. So let's say, for example, we had solved these without the calculator, so we already have the answers, but you can see how to get them on the calculator. Now, the newer calculators, like the one I have, and those of you that have the color screen ones that charge and all that, they'll be able to do this, and then I'll show you something you can do on the older models. Okay, so on a newer calculator, to get a log with a base of something other than 10, you're going to go to your math key. Then you could scroll all the way down. It's actually after 9 comes 0 and then A. It's right there, log base. But a quicker way to get that is if you press the math menu and you just hit the up arrow. You only have to go up twice to get there, which I went too many. And then you would hit enter. And now you can see you have this log on your screen with a base that you can fill in as you want to. So if we're going to do this first example here, which was log base 5, 125, I'm going to put in my 5, and then I'm going to put in my 125. And then you can just hit enter to solve it, and we see that the answer is 3, which is the same thing we had gotten when we did it without the calculator. Okay, so let's take a look at another one of those. So let's just try log base 216, for example. So if I wanted to do this again, so I would go to my math menu. I'm going to go up 2 times to get to my log base, enter, and now I'm going to type it in. I had a base of 2, and then it was times 16. And then when I hit enter, I'm going to get 4, which was the same answer we got without the calculator. So now another one that I want to try is when you have a fraction, just to make sure that doesn't throw anybody off. So if we, let's say, look at number 8, log base 16, 1/4. So if I'm going to do log base 16, 1/4, I'm going to go to math, up 2, enter. Now I have a base of 16 this time. And then when I arrow over here, I want to put in 1/4, so I'm going to do 1 divided by 4 in my parentheses. And that's how I'm going to get the 1/4. And the answer to that was 4/3. Oh, wait a second. Oh, no, it was negative 1/2. Sorry, I was looking at the wrong thing. And that is also what we got on the calculator there. All right, so hopefully that helps you out a little bit if you wanted to check your answers. If it, you still need to know how to rewrite them and go back and forth between the two methods. Sometimes I'm just going to ask you to go back and forth without actually solving it, things like that. Okay, if you do not have a calculator that has this feature, then what you would have to do, let's say you were going to do this first one up here, log base 5, 125. You have to do something called the change of base, which I believe is in tomorrow's or the next section's notes. But you would have to do the log of this larger number divided by log of the base number. And I'll show you how you would put that on your screen. So if you do not have one of the newer calculators, you would just do your regular log and you would put in 125. And then you would divide that by this regular log button again with whatever that little base number was, which in that case was 5. So this here, what I'm typing in, is going to give you the same answer as typing it in like this, log base 5, 125. It's the same thing. You should get 3. And there you go. So now let's look at this one I typed up in the top, log base 216. That was how we did it in the newer calculators. So if I have an older calculator, I'm going to have to do log 16. So whatever the big number is goes on the top, divided by log of my base number, which in this case is 2. And that should give me 4. And it does. And then if I want to do the log base 16, 1/4, same idea. I would do log 1 divided by 4 goes in my parentheses. Then I'm going to divide that by log of my base, which is 16. And there I go, I get negative 0.5 again. So that's called the change of base formula. So if you have an older calculator that still has the log key, but only for the common log, and you don't have that base that you can enter in, then you would have to use that feature. Okay, so back to where we left off now. So we left off with inverses, which is what we're going to need to do the graphing. So when you're finding the inverse, remember I said the inverse of the log is written in exponential form, right? So if you want to find the inverse of any function, doesn't matter if it's logarithmic, linear, whatever it happens to be, the first step in finding an inverse is to switch the x and y. So that's step 1, switch x and y. And 2 would be get the new y by itself. Okay, so that would be the inverse equation. So for this one, the first thing I'm going to do is write x equals 8 to the y power. Now, I want to get this y by itself, so the best way for me to do that is to get rid of this 8. Now, in order to get rid of, oops, I don't know what's happening there with this little box. All right, well, okay, so in order to get rid of this 8, if you remember from the notes yesterday, if I have a log that has a base number and then that number next to it are the same, it's going to cancel out. So if you scroll back to the top of this page here, we had gone over that, right? So right here, if I have a log with a base b and this number here is a b, it will just cancel out. So for example, we had that like with number 19 and then number 20 or whatever. So that's what we're going to try to do there. So if I just log both sides here, I have to do log base 8 on both sides. This will cancel out. I'll now have my y by itself on one side of the equation, and then log base 8x is the other side of my equation. So this would be my inverse to the original. All right, so let's try that with number 2. So number 2, first thing I'm going to do is switch the x and y. So I have x equals 6 raised to y minus 5. Now, before I can get the y by itself, I need to move this 5 over. So we're going to just do that first. So now I have x plus 5 on this side, and I have 6 to the y power on that side. Well, in order to get rid of the 6, that the y is by itself, I need to log it. And I have to give it a base of the number I want to cancel, which is 6. And then we do the same thing on the other side. Now, when you log it, though, everything's getting logged, so to speak. So this side, that cancels. So now I'm left with y all by itself. And the other side, I have log base 6 times x plus 5. And that would be the inverse function to y equals 6 to the x power minus 5. So now we're going to do the opposite. This time they're giving us the equation in logarithmic form, and we're going to get it out of that form. So if I take a look at this one here, first I'm going to switch my x and my y. Now I want to get my y by itself, so I have to get rid of this ln. So just as we did on the last two, if you remember up all the way up at the top of this page, if I have a base and I raise it to a log with the same base, they cancel out. So since I already have a log here, which in this case is just the natural log, the ln, I want to make this whole thing an exponent so that it cancels out. Now remember, ln is really a log with the base e. So if I give this a base here of e, that will cancel that out, but whatever you do to one side, you always do to the other side. So now I have e to the x power equals y minus 4, and I would need to add 4 to both sides of my equation to get the y by itself. So my y equals e to the x power plus 4. Okay, and then number 4, I'm going to switch my x and my y. Now this time, since this is all an exponent of the e, I need to get rid of that e first before I can get rid of the 3. So remember, just like we did in the first 2 problems, we logged both sides and we gave it a base to cancel that number out. Well, log base e is really an ln. So you're going to put an ln on both sides. So now on this side, I have ln of x, and on this side, I have y minus 3. And then you're just going to add the 3 to both sides of the equation. So y equals ln x plus 3. And that would be your inverse equation there. Now, what is the point of doing these inverse equations? Well, that's because typically nowadays we have these fancy graphing calculators where we have log bases. We can just kind of put them in straight away. But if you didn't have the calculator that does all that, you're going to find the inverse, get your table of values, and then switch your x's and y's and plot them, and that's how you would get the graph of your logarithmic function. Now, it says find the inverse. That's the first thing we're going to do. Find the inverse. 2, we're going to graph, and then 3, we're going to state the domain and range. So now, one thing you'll notice about inverses, and with these exponential functions and logarithmic functions, they're going to be reflections over this line here, y equals x. So this is the line of reflection that we're going to see if we do it correctly. So what I'm going to do is, to find the inverse, I'm going to do that first, right? So I'm going to have, let's say, x equals log 2y. Now I'm going to give both sides a base of a 2 so I can cancel that out. So now I have y equals 2 to the x power. So that is the inverse of this one here. So now if I wanted to graph that, I would get my points. Now we just finished doing these types of graphs in the last couple sections. So we know if we put a 0 in there, right? Anything to 0 power is 1. If I put a 1 in, I get 2. If I put a 2 in, I get 4. If I put a negative 1 in, it's 1/2. If I put a negative 2, it's 1/4. And you could get all that off your graphing calculator. So in the red, I'm going to graph this. So negative 2 and 1/4. Negative 1 and 1/2. 0, 1, 1, 2, 2, 4. And you can see the asymptote right there is y equals 0, and then it's kind of going up like this. Now, if I'm going to graph the inverse of that, which is this logarithmic function, I'm just going to switch these points. So instead of graphing 2, 4, I'm going to graph 4, 2. And then I'm going to do 2, 1. 1, 0, 1/2 negative 1, and 1/4 negative 2. And then you can kind of see it going like that. So you can see that they are, reflections of each other. And that's how you graph it. Now it says state the domain and the range. Now we're talking about the domain and the range of the log function, right? So the domain here, the x values, is where the restriction is. So if you were doing your domain and range for the exponential function, like we just did in earlier chapters, we know the domain is all real numbers, and the range is the y's are all greater than 0 in this case, right? When we do the log function, this time it's the x values that are restricted. Notice that they're all on the right side of this y-axis. So your x's must all be greater than 0. And your range, or your y values, is all real numbers. So it's going to flip-flop. All right, so let's try this now with number 2. So again, in the one color, in the red, I'll do the inverse, and then I'll go back and do the other one in the blue, just so you can compare them a little bit easier. Okay, so first thing, Okay, so let's go on to number 2. So I already have the line of reflection drawn on the graph. So we're going to start out with the inverse. So we're going to find the inverse here. So we're going to switch our x and y. X equals log base 1/3 y. Now, in order to get my log to cancel out here with the base of 1/3, I'm going to make the whole thing itself an exponent by giving it a base of 1/3. And of course, we have to do the same thing on the other side. So that will cancel out the log, and now I have my y by itself. So y equals 1/3 raised to the x power, and this will be a decay function. So getting my table of values for that equation there. So anything raised to 0 is 1, 1/3 to 1 is 1/3, 1/9, and then we would have 3 and 9. Okay, so going ahead and graphing this, I have -2 and 9, which is like just off the graph, -1 and 3, 0, 1, 1 and 1/3, and then 2 and 1/9. And this would be my decay function right here. Okay, so as we can see, the domain for that is all real numbers, and the range for that one is all the y's are greater than 0. Okay, so now in the blue, I'm going to do this log function, and really, all I have to do is plot these same values, but in reverse. So if I go over 1/9 and up 2, over 1/3 and up 1, over 1 to 0, 3, -1, and then 9, -2, it's kind of off the graph. And then it's going to look something like this. Okay, so you can see it's still, it's not reflecting where like the original and the inverse are on opposite sides of the line of reflection, but it still is going to reflect over that. So if you folded your paper on that line, it would still, the blue and the red graphs would line up on top of each other. So now your domain for the logarithmic function here in the blue, all the x values are the ones that are restricted. They're all greater than 0. And your range is the y values, so those are going up and down towards infinity, so that's why those are all real numbers. All right, so let's go down to the bottom, and we're going to do 2 more. So first thing I'm going to do is I'm just going to go ahead and sketch that line of reflection on each of these. So that is just that basic linear equation of y equals x. Same thing for this one. Okay, so now we're going to start out by finding the inverse function here. So for number 3, first thing I'm going to do is switch my x and my y. Now, in order to get the y by itself, before I get rid of the log, I got to get rid of this 1 over here. So I'm going to add that 1 to both sides. So I have x plus 1, and on this side I have log base 4y. So now I'm going to give both sides a base of 4 so that I can cancel that log out. So my inverse is y equals 4 raised to x plus 1. Okay. So now this is my table. So if I do 0 for x, that's really 0 plus 1, so that would give me 4. If I put a 1 in there, it's really like 4 squared, which is 16. And if I put a 2 in there, it's 4 cubed, which is 64. A -1 would give me a 0, and 4 raised to 0 is just 1. And the -2 would give me a -1 in there, which would give me a 1/4. So I'm going to graph my inverse. So -2 and 1/4. -1 and 1, 0, 4, and then 1/16 is like way up there, right? So here's my inverse function, which is a growth function. My domain, of course, is all real numbers, and my range is all the y's are greater than 0. So now to do my log function, which is the inverse of that, I'm just going to switch my x's and y's. So 64 and 2 would be off the graph. So I'm going to start with 16 and 1, which is also off the graph. So I'm going to go to 4 and 0, 1 and negative 1. And then I'm going to go to 1/4 and negative 2. And you can sort of see where that's going to emerge. So my domain for this one is the restricted one. X's are all greater than 0. They all have to be positive. And you can see on the graph that the graph is, so it has like a vertical asymptote this time. So that means all the X values are going to be above 0. And then the range is where we're not restricted and we can have all real numbers. Okay, and then finally our fourth graph, we're going to find the inverse first. So X equals log base 1/2 times y plus 3. Now this one's a little different because the y plus 3 is in the parentheses, whereas the last time the 1 was kind of hanging out on the end, so we got rid of the 1 first. This time we're going to get rid of the log first, but the same method, we're going to raise it from the 1/2. So now, on one side we have 1/2 raised to x, and on the other side we have y plus 3. So now we're just going to move that 3 over. So we get y equals 1/2 to the x power minus 3. So now you can see we have that k value there. So our asymptote's going to change a little bit. So now that I have that, I'm going to do my table of values. And I have -2, -1, 0, 1, and 2. So if I put in a 0 there, I would have 1 minus 3, which is -2. If I put in a 1, 1/2 minus 3 is -2.5. And if I put in a 2, 1/4 minus 3 would be -2 3/4. If I have a -1, that flips it. 2 minus 3 is -1. And if I put in a -2, that flips it, and I would have 4 minus 3, which is 1. So -2 and 1, -1 and -1, 0, -2, 1, -2.5, and then 2, -2 3/4. And you can kind of see how it's leveling out at that asymptote of y equals 3. So our domain for this one was all real numbers, and our range would be the y's are greater than -3. So now let's do the log function by switching these. So 1, -2 over 1 down 2, -1, -1, -2, 0, -2.5, 1, -2 3/4, 2. So you can kind of see what that one's going to look like. So now in this case, it's a little different. This kind of here is looking like this is a vertical asymptote. Like notice they're getting very close to this -3 here, but it's the x's that are greater than the -3, and then the range is the all real numbers. And that's it for graphing. Now, of course, if you have a calculator and you wanted to go to your y equals, if you have one of the newer calculators, it's a little more feasible to do this to check your work. Obviously, I just did the whole page without a calculator, so you don't need it. But if you were going to type this in and you wanted to type in, let's say, number 4 exactly the way it was just written, you would go into your math, go to your log base. Our base was 1/2, so I'm going to type in 1/2 there. And then in here you had x plus 3, whoops. And then you would just graph it, and you should be able to see the graph like that. Okay. So now let's go back to our notes, and we're going to do these couple word problems here. Okay, so the winning time in seconds in the women's 400-meter relay at the Olympic Games from 1928 to 1996 can be modeled by the following function. where T is the number of years since 1900. The US won in 1988. What was their winning time? So 1988 would mean how many years from 1900, right? So we know that that's going to be 88. So if we wanted to work out this function, all we're going to do is substitute that number in. So 67.99 minus 5.82 times ln of 88. And then you're just going to see what that equals. So on your calculator, you are going to put in 67.99 minus 5.82 ln, and then in there, in the parentheses, you're going to do your 88, close the parentheses, it equals, and you get 41.93, and this would be seconds. And that's pretty much it. Okay, let's take a look at the next one. The wind speed in miles per hour near the center of a tornado can be modeled by S equals 93 times log D plus 65, where D is the distance in miles that the tornado is traveling. Estimate the wind speed near a tornado's center if its path is 150 miles long. So again, we're just substituting in that number. So in the parentheses there for D, you're going to put 150. So on your calculator, you can put it all in at once. 93 log 150. Oops, sorry. Plus 65. And you get 267.38. 267.38, and that is going to be miles per hour. Okay, and then now finally the third one. Biologists have found that an alligator's length in inches and the weight in pounds are related by this function. Estimate the weight of an alligator that is 10 feet long. So normally you'd say, oh, I'm just going to enter in the 10, except that it's in feet, but they want to find it. They're saying it's in inches. So 10 feet is 120 inches. So just be careful. Sometimes they try to trick you with that stuff. So we're going to plug that in, but the 120 is going to go in for the L because that's the length. And then we're going to get this W by itself. So the first thing we want to do is add this 32.8. So that's going to give us 152.8 equals 27.1 ln W. And now I'm going to divide that by the 27.1. So I have ln of W equals, and I believe I get 5.633. So if you check it on your calculator, 152.8 divided by 27.1. 5.638. Okay, now in order to get rid of the ln, we have to make that an exponent because remember, this is really log base e. So if I give it a base of e, that'll cancel out. So this means that my W equals whatever I get when I do e raised to 5.638 on my calculator. So I'm going to do e raised to 5.638. If you want to put more digits, you can. And it's 280.9. 280.9, and I believe that's going to be pounds. And there you go. All right, so hopefully that helps with the graphing. You're really finding the inverse, which is the same thing we spent last week graphing. You could use your graphing calculator if you have one of the newer ones to put the log functions in and graph it from there. The domain and range is also basically the opposite of what we were doing with the exponential functions. and then plugging into formulas here. No big deal, just using your calculator. So today's lesson was really just about the inverse and the graphing and using your calculator a little bit. And that's it. Hopefully you guys have an awesome Memorial Day weekend, and we will meet up again next week. Thanks.